taking a look at solving equations with radicals. Now, when we solve an equation for a radical, we simply are going to use our inverse operations to isolate the variable which will appear underneath the radical. So for example, if I had -2 times the square root of x and set that equal to 6, I'd want to get x by itself in order to know what the solution is. Now, we have to be careful in some of these situations because we may be presented with an extraneous solution. Now, this is a possible solution that's obtained but does not check out in the original equation. And this is an example of that. So if I were to solve this for x, I'm going to divide both sides by -2 first. And when I do that, I have the square root of x is equal to -3. So in other words, the square root of some number has to be equal to a negative number. However, we know that's not possible. Whenever we take the square root of a number, it's always going to be positive. So this is an example of an extraneous solution. Now, if we were to continue solving this, we're going to undo the square root by squaring. What you do to one side, you got to do to the other side. So we would square both sides, and we'd end up with x is equal to -3 squared, which is 9. Now, if we take that 9 and substitute it back into our original equation for x, we would end up with -2 times the square root of 9 is equal to 6. So here you see that -2 times the square root of 9, which is 3, should be equal to 6. However, -2 times 3 is -6, and -6 is not equal to 6. So this proves that this is an extraneous solution, and there's actually no solution to this original equation. All right, let's get some practice. Let's get some practice solving some of these equations with radicals in them. All right, we're going to start by isolating our variable, which is the z underneath the cube root. We'll subtract 4 from both sides. We have the cube root of 3z is equal to 3. Now, to undo the cube root, we have to cube both sides, and that leaves us with 3z is equal to 3 cubed, which is 27. And finally, we divide both sides by 3, and z is 9. Now, you should always go back and you should substitute that number back into the original equation to make sure it works. 3 times 9 is 27. The cube root of 27 is 3. 3 plus 4 is 7. All right, let's move on to example B. We want to get p by itself here under the radical. So we're going to start by multiplying both sides by 6 to get rid of it on the left side. And that leaves us with the 8th root of p minus 7 is equal to -6. Now, let's isolate our 8th root of p by taking that -7 and adding it over to the other side to get a +1. And now we're going to take and we're going to do the inverse operation of the 8th root, which is the 8th power. And 1 to the 8th power is simply 1. So p is equal to 1. All right, example 3 is an easy one here. We already have our variable isolated. It is the cube root of x is equal to 4, so we're going to cube both sides. When we do that, x is equal to 64. Letter D is a little bit more complicated. We're going to start by getting the 25 over the other side by subtraction. So we'll subtract both sides. Now be careful, this negative here is a part of the 16, so our next line needs to read as such: -16 times the cube root of f plus 1 is equal to -7 plus -25, which is -32. Now we'll divide both sides by -16, and we end up with a cube root of f plus 1 is equal to 2. All right, now let's get f plus 1 by itself by taking the cube of both sides to undo the cube root. That leaves us with f plus 1 is equal to 8. Subtract our 1, and f is 7. All right, in our next example, now we need to be careful of some extraneous solutions here, and you'll see what we mean right here in example A. Let's start by getting the 6th root of 2b by itself. We'll subtract 8 from both sides, and that gives us the 6th root of 2 times some number b is equal to -5. Now, your little light bulb in your head should be going off here. We have an even root and a negative number. This is not possible, and therefore we're going to end up with an extraneous solution. Let's see if we can spell it right. Extraneous solution. So you'll get a solution. You can keep solving this problem. However, it won't check out in the final answer. So in order to get that extraneous solution, we're going to take the 6th power of both sides. And that gives us 2b is equal to 15,625. And then we're going to have to divide that by 2, and that would give us a value for b to be 7,812.5. And we say that this is an extraneous solution, and really this entire equation is not possible, or we say that it is not defined. All right. Letter B now, we have 5 times the square root of 3y plus 1 equals 80. We'll start by dividing both sides by 5, and that gives us the square root of 3y plus 1 is equal to 16. Undo the square the square root by squaring both sides, and that leaves us with 3y plus 1 is equal to 256. We'll subtract our 1. 3y is equal to 255. Divide both sides by 3, and y is going to be equal to 85. All right, just a few more examples. Example C is actually a typo. That should be the 4th root of x. So go ahead and change that on your notes. We'll make our variable be under that 4th root. All right, so let's start by subtracting 7 from both sides. We have the 4th root of x is equal to -2. Bing bong, your light bulb's going on. You got an even root set equal to a negative number. Here you can say this is not defined, or undefined is fine as well. All right, now this is going to be an extraneous solution, and you can go ahead and find that solution by taking the 4th power of both sides, and that means x would be equal to a positive 16. However, if you were to plug that positive 16 back in, the 4th root of 16 plus 7 is not going to be equal to 5. All right, final example here. We got the cube root of 3x plus 4 is equal to 7. So we're going to start by undoing the cube root, take 7 and raise it to the 3rd power. That gives us 3x plus 4 is equal to 343. Subtract our 4, that gives us 3x is equal to 339, and then divide both sides by 3, and x is equal to 113. All right, that last example, E, in your notes is a doozy. You try that one on your own. We'll check it tomorrow in class.